We're now going to discuss multi-dimensional arrays in C#. Now, C# is different from some other C-based object-oriented languages in that it supports both rectangular multidimensional arrays and jagged multidimensional arrays. And for the purpose of this example, we'll do two-dimensional arrays just for simplicity. Now, with a rectangular array, you are guaranteed that every single row in the array has the same exact number of columns, and you use one indexing syntax for that style of array. With a jagged multidimensional array, and specifically two-dimensional array, it's possible for every row of the array to have a different number of columns. And the reason for that is a jagged array is really a one-dimensional array in which each element refers to a one-dimensional array. This is in the context of 2D arrays, like I said for this example. Of course, you can also have more than two dimensions for both different types of arrays. So what we're going to do in this example is show you how to declare and initialize both rectangular and jagged arrays, and also how to walk your way through the elements of both rectangular and jagged arrays. So you'll notice right away as we look in our initArray class's main method that we have two different styles of declaration here. This first one is declaring a rectangular array. The number of dimensions is determined by the number of commas inside the set of square brackets. 1 comma means 2 dimensions, 2 commas means 3 dimensions. So basically, whatever number of commas you see there, the number of dimensions is that number plus 1. So in this case, it's a two-dimensional rectangular array of rows and columns where when indexing through the array, the first index number represents the row number and the second index number represents the column number. And as with one-dimensional arrays, all indices start from 0. Now on the right side of the equal sign here, we have an initializer list that lists out the set of values for each of the rows in the rectangular array. So the first row is going to be initialized with the values 1, 2, and 3, and the second row is going to be initialized with the values 4, 5, and 6. So that's one type of multidimensional array, and we'll go ahead and output that in a moment. The other type is a so-called jagged array where each row can actually represent any number of columns. And notice how you specify the number of dimensions for a jagged array. It's each set of square brackets represents one dimension. So we have two sets of square brackets here. Therefore, this is a two-dimensional integer array in which the first set of square brackets represents the rows and the second set represents the columns. Now you initialize a jagged array in a similar manner, but you'll notice each of the rows initializers is creating a new array object in this case, an array object of integers that's a one-dimensional array containing the values for that row, the column values for that row. So in this jagged array, the first row, row number 0, has a set of values that consists of 2 columns with the values 1 and 2. This second row, row number 1, contains just the value 3, and the third row contains the values 4, 5, and 6. And we call it a jagged array because you can see here that the number of elements per row differs for each of the rows. That's not a requirement. You can certainly have a jagged array where all of the rows have the same number of elements, but in this case, I purposely showed you a jagged array with different numbers of elements for each row. Now, we have overloaded output array methods in this example, one that knows how to receive and output a rectangular two-dimensional integer array, and one that knows how to receive and output a jagged two-dimensional integer array. So you can see that we're calling the two different versions of output array in lines 21 and 23, and based on the argument, it knows which version of the method to call. When I hover over this first output array, you see that the parameter declaration shows a comma inside of square brackets. That means it's expecting a two-dimensional rectangular array. And in the second one, when I hover over the method name, you see two sets of square brackets, which means it's expecting a two-dimensional integer array that is a jagged array. So let's take a look at our implementations of the two different output array methods. At lines 27 through 40, we have the output array for a rectangular integer array with 2 dimensions. and we're going to walk our way through the rows and columns. Now for this one, we've used a counter-controlled nested for loop, where the first for loop specifies which row we're looking at, and notice how we obtain the length of the number of rows, I should say. The getLength method of class array, remember every array you create is really an instance of class array. The getLength method tells you for a given dimension number how many elements are in that dimension. So when you're talking about the rows, which is the first dimension of a rectangular array, the first dimension is represented with 0, the second dimension is 1, the third dimension is 2. So getLength with 0 tells me how many rows there are in the array object, and I will then iterate through that number of rows. And similarly, at lines 35 and 36, we have a nested counter-controlled loop for the columns, and notice that we're determining the number of columns by calling array.getLength with 1 as an argument, which gives us the number of columns, the number of items in the second dimension of the array. Now, as far as indexing into the elements, this is different for those of you coming from Java or C++, for example. Notice that we index in a rectangular array using row, comma, column as the indices, and that's going to go to the particular row and column, grab the value, and we will then output that value. And you can see when we're done with a given row, we drop to the next line. And when we're done with our call to output array, we are also going to display a new line to move to the next line of the output. Now, I could have used a for each repetition statement here. However, the problem with a for each repetition statement is it treats the two-dimensional array like a one-dimensional array. So you would actually not use a nested for each statement in the context of a rectangular array. You would just iterate through all the elements of the rectangular array with a single for each statement, and the issue with that is it doesn't give you the row by row set of values. So if you really want row by row processing, then you would use a nested counter-controlled loop as we did here in this version of output array. So let's stop there for a moment and run the program, and we can see that the values in the rectangular array by row are 1, 2, 3, 4, 5, and 6. Now the other output array method receives a jagged integer array. So this is really an array of integer arrays, an array of integer arrays. And at line 45 we then display that we're going to display the jagged array by row. And here we have nested for each repetition statements. And this works because of the fact that it's really an array of arrays. So you can use either counter-controlled looping or for each nested statements as we're doing here when you're dealing with a jagged array. The first for each, notice, is declaring the range variable row to be an integer array. Again, it's an array of arrays, so each element of the main array is actually an integer one-dimensional array. And then within that row, each element within the row is an integer. So notice again the difference in how the range variables are being declared here. So the first one is an array of integers, the second one is just one integer in the current rows array. And one element at a time then we're able to display the value. At the end of a given row, we drop to the next line and continue with the next iteration of the outer for loop. And as you can see, when we go back over to the output, we were indeed able to display the appropriate set of values for each row based on the way that we initialized the array jagged. So again, if you're dealing with two-dimensional arrays, you have two choices, rectangular arrays and jagged arrays. You have two different ways of declaring them. Rectangular arrays use commas in one set of square brackets. Jagged arrays use the number of dimensions as separate sets of square brackets. And then the way that you iterate through them varies depending on what you need to do in your program. Most commonly with a rectangular array, you would probably use nested counter-controlled loops if you need access row by row through the values. And in the case of a jagged array, you can use either counter-controlled repetition or nested for each statements to access the elements.